Okay, we're going to be looking at graphing quadratic functions, and up till now you've only looked at graphing using the step pattern. You're going to use a new method called mapping notation. So let's start by looking at the review because we will be looking at determining the vertex of a quadratic function first before we can actually use either step pattern or mapping notation. So in the review we have state the vertex for each of the following. The first equation is y equals -2 x plus 3 squared plus 5. You'll notice this equation is already in vertex form, so all we really need to think about is how the graph has been shifted in order to determine where the vertex would be. So this graph has been shifted to the left 3 units and up 5 units, so that tells me that the vertex has moved to the left 3, so -3, and up 5, so at +5. The second one says y equals 3x squared minus 18x minus 2. And you'll notice this equation is actually in standard form. We do need to rewrite this into vertex form first before we can actually determine the vertex. So we use a method called completing the square last year. And so let's try doing that. So if you remember from last year, when you are completing the square, your goal is to try to write the equation that's in standard form and make it look like the equation that is in vertex form, like what we have up here. Okay, the goal is to make it look like y equals a x minus h squared plus k. We're going to start by focusing on the first two terms, and if there is a coefficient in front of the x squared term, we do need to factor it out. In this case, we do have a coefficient, so we're going to factor out the 3 from just the first two terms. And we'll be left with x squared minus 6x. The minus 2 at the end is just going to stay the way it is until pretty much the last step in the problem. From here, we're going to try to make the x squared minus 6x part look like a perfect square trinomial. So if you remember from last year, we used to take the middle term here. We would divide it by 2 and then square it to determine what that number would be to create a perfect square trinomial in the brackets. 6 divided by 2 is 3. 3 squared is 9. So that's going to be the number we're going to add and subtract in the brackets to get x squared minus 6x plus 9. That looks like the perfect square trinomial that we need, but we need to rebalance the equation by adding a minus 9. So it seems like we're not really changing it. And then we want to keep the x squared minus 6x plus 9 part, and we want to get rid of the minus 9. So if I take it out of the brackets, I also have to look to see if there's a coefficient at the front, because this 3 at the front actually sort of introduces the distributive property. So you're actually going to multiply 3 times x squared, 3 times 6x, 3 times 9, etc., etc. So anytime you pull any of the terms out of the brackets, you need to make sure you multiply it by the coefficient at the front. So we get y equals 3. X squared minus 6x plus 9. I'm going to take the 9 out, the -9, and I have to multiply it by the 3 that was at the front, and then the minus 2 was still at the end. So what I'm left with is y equals 3. This part here is a perfect square trinomial, which I know how to factor. So I'm going to square root the first term, and I'm going to square root the last term, and I'm going to keep the sign of the middle term, so it'll be x minus 3 squared. A faster way of determining this is to actually take the 6 and divide it by 2. So take the -6 and divide it by 2, and that'll give you the second term in the binomial part that's here. For the rest of it, I have -27 minus 2, which is equal to -29. Okay, so that tells me that the vertex should be at 3 and -29. The graph has been shifted to the right 3 and down 29. Alright, so let's take a look at some of the information that you should know from last year. So just a review of quadratic functions, or what you remember as quadratic relations. So a quadratic function is a function that contains an x squared term. Okay, when you see an x squared term, and that's the highest exponent term in your function, that indicates that it is a quadratic function. The graph of a quadratic function is a parabola. That was a name that we used to describe a quadratic function. It looks like a U-shaped curve, either opening up or a U-shaped curve that opens down. If a parabola opens upward, the graph has a minimum. So here's an example of a parabola that has a minimum. It's opening up. If a parabola opens downward, the graph has a maximum. So here is an example of a parabola that opens down and okay, so just to remind you, the reason why the way you can tell whether there's a maximum or there's going to be a minimum is by looking at the coefficient of the x squared term. And if the coefficient of the x squared term is positive, you know the graph is going to open up, which means there will be a minimum. If the coefficient of the x squared term is negative, that means that the graph is going to open down and you would have a maximum value instead. Okay, looking at vertex form, so y equals ax minus h squared plus k. It really doesn't matter what variables you have here. It doesn't matter that it's h and k. What you do want to remember is where those values are located. The transformations that are applied are really what indicate what the vertex would be. So a shift to the left or right or a shift up or down is really what you're looking at. It doesn't really matter that the letters we're using are h and k. In terms of the vertex, when the equation is in vertex form, it's very easy to see where the vertex is. The horizontal shift tells you what the x-coordinate of the vertex is, and the vertical shift tells you what the y-coordinate of the vertex will be. If a is greater than 0, so if the value of a is positive, you have a minimum value of k. So if you know that the parabola is opening upwards, then the minimum value is actually the y-coordinate, and that happens at the x-coordinate, which in this case would be h. If the value of a is less than 0, which means it's negative, then you would have a maximum value of k since the parabola opens downward. So that would give you the maximum value. And that occurs when the value of x is equal to whatever the x-coordinate of the vertex is. Okay, I usually like to use a happy face and a frowny face to help me remember it. So if I know the coefficient of a is positive, then I know it's going to open up. If I know it's going to be negative, then I know it's going to open down. So the max min of a quadratic function may be determined quickly if the function is in vertex form. So anytime you're looking at a max or a min, you just need to make sure the equation is in vertex form. Therefore, we must complete the square or use a shortcut. So I'm going to show you guys a shortcut in the next example. So in example 1, it says determine the maximum or minimum value of the following quadratic function. I know the answer is at the bottom. We're going to hide it for now. And then it says and state when it occurs. So we want to know what the maximum or minimum value is and when it actually happens. Okay, so if we think about how to get the maximum or minimum, the maximum or minimum is easily identified if the equation is in vertex form. So my goal is to rewrite this standard form equation into vertex form. There's a couple of different ways you can do this. One way is by completing the square, so that'll be one of the methods I use to show you. And then the other method is by using a shortcut. So let's start by using the one you're familiar with. So if I have y equals negative 2x squared minus 4x plus 3, first thing I'm going to do is focus on the first two terms so that I can get this into vertex form. If there's a coefficient in front of the x squared term, I'm going to factor it out of both terms that I have in the brackets. So that'll give me x squared plus 2x plus 3. And then I'm going to determine what the value is that would make the brackets a perfect square trinomial. So 2 divided by 2 squared is what I'm going to add and subtract. So 2 divided by 2 is 1. 1 squared is 1. So I have x squared plus 2x plus 1, minus 1, and then plus 3. And then I'm going to eliminate the negative 1. So I have x squared plus 2x plus 1 minus 1 times negative 2 plus 3. And if I finish factoring this, the perfect square trinomial factors to x plus 1 squared. Negative 1 times negative 2 is 2, plus 3 is positive 5. Okay, so there's the equation in vertex form. So I know that I'm going to have a maximum value because the parabola is opening down. And I know the maximum value is going to be 5. And it occurs when x is equal to negative 1. Okay, so this is one way to get the equation in vertex form. Now the shortcut is a little bit different, and the shortcut works all the time as long as the original equation that's given is in standard form. All it requires you to do is to write the equation in using the formula here. So writing x equals negative b over 2a. Now this little formula here will help you find the x coordinate of the vertex, and it works every single time. So the a and b value just come from the coefficients of x squared and x. So I'm going to substitute those in. So I get negative 4, and I get 2 divided by negative 2. And so I get x equals negative 4 gives me 4. And 4 divided by negative 4 gives me negative 1. So what this actually gives me is the x-coordinate of the vertex. Now I can solve for the y-coordinate of the vertex, and it's pretty straightforward. If I know the x-coordinate, I can substitute back into the original function to figure out the y-coordinate. So I get y equals negative 2 times negative 1 squared minus 4 times negative 1 plus 3. So that gives me negative 2 times 1 plus 4 plus 3, which gives me negative 2 plus 7, which is equal to 5. Okay, now that I know the x and the y coordinate of the vertex, I can actually write this in vertex form. My a value never changes. Okay, so I can rewrite this in vertex form and get y equals negative 2. And I know that my vertex is at negative 1 and 5, so I can use that to substitute into the vertex form equation. And so I would get x plus 1, remember the sign always looks opposite, and then plus 5. Okay, and if you look at what I have here, and if you look at what I have here, they're exactly the same. So it doesn't matter whether you use completing the square or whether you use a shortcut. You have 2 new methods that you can use to actually get the equation in vertex form. This one you do need to do some factoring. In the shortcut, all you're really doing is you're finding the x-coordinate of the vertex and then substituting in to find the y-coordinate. Okay? And then once you have the vertex and the value of a, you know how to write the equation in vertex form. Okay? So just to finish up the question, the maximum value of y is 5. You can see that by the end value that we have. And it occurs when x is equal to negative 1.